In this video, we will look into the statement, if statement, if else statement, and if then and else statement. Okay, and also we will evaluate loop looping. Okay, normal coding that we have learned before is just a straight coding. We start our system and then we begin to execute a first instruction followed by the next instruction, and again next after next after next instruction until we turn off our system. Okay, so this one is very simple. We just start and put our coding here. What is our first coding? Let's say we want to load data. We load data, we compare that, we load data, we add data, we shift data, we rotate, we multiply, we AND gate and OR gate, and etc. That we consider as a straight line coding. Okay, so next we will look what happen if we put if statement, meaning that the coding now is not strict anymore. It got a branch like this. Okay, for if statement we put if here. If the condition r1 is equal to 0, so for if statement there will be two options. Either this condition is true or not true, or we call it a true or false. So for if statement, in this example, if the condition of r1 is equal to 0, if the condition is true, meaning that yes, r1 is equal to 0, micro p will execute this conditions true statement. Okay, but if this condition is not true, let's say the content of r1 is not 0, maybe 1, 5, 10, 100, 1000, or minus 17, minus 1000, minus 1 million. Other than 0, we consider that the condition is not true or false. So for this statement, micro p will take this branch and skip, okay, and skip this condition true statement, meaning that the condition true statement is only execute for the condition true only. If not true, this condition will be skip or will not execute. Skip to execute next instruction. So next after next again. Okay. So for the coding, here we compare. We must compare R1 with 0. In this example, we compare R1 with 0, and then branch if not equal. Not equal to what? Not equal to 0. So branch meaning that this is a normal flow. So branch is referred to the branch here. If the processor will take this branch and then it will go to execute another set of program. In this case, it will skip this condition true statement. So compare R1 with 0. If the result is not equal to 0, we instruct the micro P to branch. Branch to where? Branch to, in this case, I name the branch as a branch. The name for the branch is branch. So branch if not equal 0 to branch. So where is branch? Here is the branch. Remember, this column in a coding, this column is represent label, this column is represent mnemonic or instruction, and this column is represent operand followed by the comment here. If we have any comment, we can put our comment after this operands. So in this example, we instruct micro P to branch. So if the condition is not true, micro P will go here and then we run next instruction, skip this true instruction. So here since micropy not execute for conditions not true, micropy will not execute anything from BNE branch until this branch level. Yeah? So it will skip this. So here we can write any condition true statement. Maybe here under this box you will have 100, 1 or 2 or 10 or up to 100 line of instruction. It's up to the programmer. Okay, but here is the condition of if statement. Okay, that is quite simple. Okay, next, if else statement. Okay, for this statement we compare. We use the same example. If R1 is equal to 0, if the condition is true, we straight go to execute add R1 or R3 instruction. But if condition is not true, meaning that other than 0, we will execute another set of condition else statement. So it's contradict with the previous example. Okay, here we execute the condition statement if the condition is true, but for this one we execute the condition statement if the condition is not true. Okay, but for this kind of flowchart, we can convert to become like this, because normally branch we is referred to here when micropy execute any program outside the straight line. Here we call it a branch. So in this case, in this example, if R1 is equal to 0, we branch if yes. In this case, we branch if no. So if branch if yes, condition true will be for no. Condition no, this one is condition no statement. Condition not true statement. Okay, but we use here we put no, and for branch we put yes, meaning that if R1 is equal to 0, we will skip this condition not true statement. So this flowchart is similar with this flowchart, because if yes we skip, but for this one if yes we skip, but we declare yes as a branch. Okay, so for coding we compare R1 with 0. Branch if not equal, in this case is not equal, right? If not equal, we go to branch. Here is branch, here is the coding for branch, and then here we can write any instruction that is for condition else statement. Here, if after we finish execute this instruction, we branch back to here. Okay, we write this condition here, and then after finish we branch without condition, branch always to here, branch return, and then we proceed with next instruction, and here next after next. Okay, but this is a little bit confused for certain programmer, but for this one is similar like the previous one, except that instead of we branch not equal, in this case we branch if equal, meaning that BEQ, branch if equal to 0, branch to here, branch, and then here it is the condition true statement or condition true coding or instruction. We can write any condition true instruction here, and after this we finish with add, followed by next after next after next. Okay, next. Next is if then else statement. For this kind of statement, we have we got both statement either for condition true or condition is not true. Here, if R1 is equal to 0, if condition yes, and then we execute this set of instruction. If condition is no, we execute this set of instruction or condition else statement or instruction, and both will be returned back to the main program using this branch return. Okay, so here we compare R1 with 0, branch if not equal, here branch if not equal, and then we execute branch if not equal to branch here. So here is the condition for else, condition else statement, finish here, and then we branch to return, branch return here in this case. Yeah, I put this coding in line with this box. So for condition yes, we write the coding for condition yes here, and it will finish here, and then it proceed to execute this add instruction. So for new program, we can add here new program, next program, next program, next program. Okay. This is the first way you can do it, but maybe it's confused for a certain programmer. The second choice that you can use is like this. We use the same flowchart. Yeah, the same flowchart, exactly the same flowchart. If condition yes, here. If condition no, here. And both will return to main program using branch return. We compare with 0, branch if not equal. Yeah, not equal, we take the branch. Here is the branch. And then here, branch is not equal, branch here. We write all the coding for not equal, coding else statement here until here. And then for condition true, we write here. Condition then yes or true, we write here until finish here. And then we use branch here. We use branch always here. Why? To skip this set of condition else statement. If we didn't put branch to branch return here, branch return refer to this line. If we didn't put this instruction to skip this condition as statement, microP will execute both condition. It will start with it will start to execute a condition then statement. After that, it will execute condition as statement. Okay, it will execute both statement. But if we use a branch to branch return, here's branch return, microP will skip this condition else statement. We skip and then return back to branch return here and start to execute the next instruction. Tambah R2, R3, divide R1 by 8 here, by 3. No, in this case, divided by 8. So this is the coding. Because we use arithmetic shift right, we shift 3 bit, meaning that we divide by 8. If we shift 1 bit and divide by 2, if we shift 2 bit, divide by 4, 3 bit by 8, 4 bit 16, 32, 64, etc. Okay, so this one is very simple or straightforward. So up here is any coding before this branch, and down here is any coding after this tambah instruction.